Okay, so here's our second example. So again, we've got a second set of numbers. Okay, we don't have a context. I've not given you any contexts for the examples, but it could be anything. It could be the number of pupils absent in a class on however many different days or something like that. It doesn't change what we're going to do. First thing I always want you to do, folks, is work out the mean. Now, the question will often ask you to work out the mean, but if not, you need to do it anyway for the method that we're using to work out the standard deviation. So to work out the mean, I'm going to use the notation. So we add up all the x's and then divide by the number of numbers, and the mean we're now calling x bar. So we're using some kind of slightly more sophisticated mathematical notation. Add up all the numbers. Okay, you probably want to grab a calculator for this one just to make sure. 1, add 3, add 3, add 4, add 8, add 9, add 11, add 21. And we get an answer of 60. And remember, you should double check that before you go any further. And then divide by n, the number of numbers, which in this case is 8. Now, in this case, 60 divided by 8 doesn't work out nicely. We get a mean of 7.5. Now, that looks roughly right. That would go in here, okay, in terms of the numbers. Okay, so that again looks like a sensible answer for our mean. It is a little bit unfortunate, though, because it means that when we come to working out the standard deviation, we are going to be working with a decimal when we do our table, and that is not quite so fun, but you need to get used to doing it. There is another method of working out the standard deviation which would avoid that, okay, but equally it has its own issues. So we're going to continue using this method. You just need to make sure you're really careful with your decimals here and that you don't round them, okay? So I don't want to see any rounding here. You just make sure you make your table big enough to deal with this, okay? So our x's are our numbers, and we might need to make this table a wee bit bigger. We'll get it started. Our x minus x bar is the number take away the mean, and then we're going to have x minus x bar all squared. Okay, and you'll get very used to doing this. So I know it's new to you, but you'll remember the three columns of the table really, really quickly. Okay, our numbers were 1, 3, 3, 4. So 1, 3, 3, 4. And then 8, 9, 11, and 21. So 8, 9, 11, and 21. Okay, so I'm just going to make my table a wee bit longer. There we go. Okay, and just as a wee reminder, the mean was 7.5. Okay, so the mean was 7.5. Now, some of these I can do without a calculator quite easily. In fact, we should be able to do them all without a calculator. 8 take away 7.5 would be 0.5 here. 9 take away 7.5 would be 1.5. This would be 3.5. Okay, but you're not going to be asked to do this question without a calculator. Okay, so for the top row, we've got 1 take away 7.5. That gives me minus 6.5. Now, while that's on my calculator screen, I'm just going to do the next column. I'm just going to square it now. Okay, so I then just press squared equals, and I get 42.25. Now, this isn't too bad. The decimals are looking okay, but remember, if it was 0.2578, okay, you would need to put all 4 decimal places. So put as many decimal places as you've got on your screen. Don't do any rounding. Please don't write that as 42.3 because you're going to get the wrong answer. Next one, 3 take away the mean. So 3 take away 7.5. That gives me negative 4.5. And I can square that. I'm just going to square that now while it's on my calculator screen. And I get 20.25. And then, obviously, the next row down is 3 again. So we're going to get the same answers. Okay, the next one is 4. So 4 take away 7.5 is minus 3.5. And then I square that. And I get 12.25. Okay, then you can check the next 3 if you want. But we're doing 0.5 squared, which is 0.25. We're doing 1.5 squared, which is 2.25. We're doing 3.5 squared, which is 12.25. Because obviously minus 3.5 squared was 12.25. So if you think about it, they're going to be the same. Now, finally, 21 take away 7.5 is 13.5. And if we square that, we're going to get a big number here. We're going to get 182.25. Okay, so to get the sigma of x minus x bar all squared. We're going to add all these up. Okay, now it's quite a long column to add up. Remember, any time we're doing this kind of adding up, it's best to do it twice. Okay, so double check your work. So I've got 42.25 plus 20.25, and again 12.25, 0.25, 2.25, 12.25 and 182.25, and you should, if I've done it correctly on my calculator, you should get 292. So it actually works out as a whole number, okay, just because all the 2.25s were a multiple of 4. Okay, but you could end up with a decimal there, so don't panic if you're doing a question and you get a decimal there. From there, okay, we write down our formula. So the standard deviation is the square root of the sum of the x minus x bar all squared divided by n minus 1. Now, it's the square root then of 292 divided by, right, let's go back up and check. We had 8 numbers, n was 8 when we were working out our mean, so n minus 1, 8 take away 1 is 7. So this time clearly we need a calculator. It's not like the previous example where all the numbers worked out nicely. We've got 292 divided by 7, which is 41.71428 and so on. I'm not even going to write that down. I'm just going to square root that straight away and get 6.45. So you could type it all at once now. You know to give me an unrounded answer first. And then let's say this question asks for it rounded to 2 decimal places. We would have 6.46, or that would maybe be 3 significant figures. Okay, so thinking about our rounding. So there's a second example. It might be worth you trying to go away and do a few of the examples on the worksheet that I've given you, the first sheet, okay, just to get a feel for it. Come back and watch the video again if you need to. Get in touch with me if you need to. But I want you to stop before you get to the questions where it asks you the wordy stuff. Okay, so where it asks you to do the comparing. Okay, there'll be like a part B to the question, and there's going to be a third video you can watch that's going to talk about how we compare mean and standard deviations between 2 different sets of data. It's quite like what we did with box plots, but I didn't really explain it to you. It's something we'll do in August, so don't worry if you can't really get your head round it. Okay, concentrate on just can you work out the standard deviation, and we'll talk about this this is the kind of more English bit of National 5 Maths where you've got to do the chatty stuff. Okay, but we'll try and get to that and do a bit of that with the next video. But if not, just concentrate on using these 2 videos to be able to work it out, and get in touch with me if you need some more examples, because that's only 2 examples that I'm expecting you to work from.